Good morning. In our lecture today, we are going to talk about ARMA models. So ARMA is divided into AR and MA. So we have to understand each one of them separately and then talk about the ARMA. ARMA or AR or MA models, they are time series models, which means they are depending on time series data. So let's start with the AR model or autoregressive model. And AR models have order B. AR models are models where the dependent variable depends on its lab values. So say, for example, this is x at time t. It depends mainly on its lab values. So for example, this is rho xt minus 1 plus epsilon t. So this means x depends on its lab value and thereafter, where rho is the coefficient to be found and epsilon is the error term. As t is t minus 1. So this minus 1 is the order of AR. So this means that this model is AR1 model, which means it has only one factor. So the general form of the AR model, which is ARB, equals xt equal summation from I equal 1 to b rho I xt minus I plus epsilon t, where I is just like a character. So if you would like to write AR3, for example, so this counter will be 1, 2, and 3. So we can write the model as xt rho 1 xt minus 1 plus rho 2 xt minus 2 plus rho 3 xt minus 3 plus epsilon t. So minus number of labs is the order of our model. Of course, you can add constant if you would like to. The error term is characterized by being white noise, or it has mean of 0 and variance of sigma squared. So the economic meaning of the model is that a change in the value in time t depends on its values in previous years. Stationarity of the AR model. Actually, AR can be stationary at time years with respect to the AR model. It can be stationary or non-stationary. So it's conditional to some extent. How to determine the order of the ARMA? The order of the AR model is determined based on what's known as ACF and BACF figures. This depends on the ARF, ACF, and BACF. Here is an example. On the left-hand side, this is the ACF or autocorrelation function. And in the right-hand side, this is the BACF or partial autocorrelation function. As you can see, that there is a gradual decay in the ACF. If there is a gradual decay, this means that this is AR. And then to determine the order, we have to see the partial ACF. As there is a cut-off after, here in our example, cut-off after the first two. So it cuts off sharply after 2. So this means that this is AR2 model. So from ACF, you have to determine the model, whether it is AR or not. And from BACF, you have to determine the number of lag or the B order. What about the MA? Moving average or MA. And the order of MA is known as Q. MA model shows that current value of time series is a linear combination of current and past white noise error terms. So this means that our variable depends on the error, not its lag, the lag value of the variable itself, but the lag values of the error terms. So we can write the equation as xt, for example, GDP, investment, etc. Mu is the intercept, epsilon t, error at time t, plus sigma 1, epsilon t minus 1, plus epsilon 2, sigma 2, epsilon t minus 2, epsilon q, sigma q, epsilon t minus q. So this is the general form of the model. MA model must be stationary. It can't be non-stationary. This is the opposite to AR. AR, we said that it can be stationary or non-stationary. What about how to determine that this is MA model and how to determine that the number of Q or the order of Q? Here is another example. Actually, we are going to use the same tool, which is ACF and BACF. MA is the inverse. With respect to ACF, is used to determine the order of Q, while BACF determine whether this is an MA or not. As BACF decays gradually, so this is MA model. In order to determine the number or the order of Q, we are going to see the ACF cutoff after Q decays. So this is, here is the cutoff, the first two. So this is MA2. So if you are going to compare between AR and MA, AR depends on what's the value of X, while MA what's the value of error. With respect to stationarity, AR conditional, it can be stationary or not, while MA always stationary. With respect to the ACF, it decays gradually, while with respect to MA, cut off after Q. And for BACF, cut off after B, while in MA it decays gradually. So these are the main differences between AR and MA. What about ARMA model? After the ARMA includes both, so it has order B and Q, where B is the order of the AR and Q is the order of MA. So the general form of the ARMA model, XT equal C for constant, for example, plus summation starting from I equal 1 to B, phi I, xt minus 1. Sorry, it's t minus I, where I is the number of B, or a counter counting from 1 to B, plus epsilon t, plus summation starting from I equal 1 to Q, I epsilon t minus Q, where I is a counter starting from from 1 to Q. What about the detection, whether this is an AR model or MA model or ARMA model? If you are going to look to the same ACF and BACF, ACF in this case ACF is going to decay gradually, and DACF as well decays gradually. So if both of them, ACF and DACF, decay gradually, this means that this is an ARMA model, not an AR1 or MA1. It's ARMA model. ARMA must be stationary. So this means that AR is stationary in case of ARMA model. While with respect to determining the order of the ARMA and the ARIMA model, we are going to talk about them later in our next lecture. Thank you. See you next week.